is question 9 of the Edexcel SAMS, that's a sample assessment paper for paper 2, GCSE physics. It's the higher tier one. We're hitting question 9, it's getting pretty hard now. So question 9, figure 24 shows a submarine underwater. The motor in the submarine turns the gear wheels shown in figure 25. A turns clockwise and has 30 teeth, B has 20 teeth. Gear wheel A rotates clockwise through one complete turn. Which of these is correct for gear wheel B? Now, if A is turning clockwise, any gear that is next to it will turn the opposite way. So if this turns clockwise, B is going to turn this way. So it's going to be anti-clockwise for B, so it's going to be either B or C. And then for every turn of A, which has 30 teeth, B has 20 teeth, so it will turn 1.5 times. So we're going to say that 1.5 turns is going to be either this one or this one, so it must be B that we're looking at there. Then, part B. A bubble of gas escapes from the submarine. The volume of the bubble is 23 centimetres cubed. The pressure of the gas inside the bubble is 297 kilopascals. The bubble rises to the surface without change in temperature. Calculate the volume of the bubble when it reaches the surface. Atmospheric pressure is 101 kilopascals. Use an equation from the formula sheet. So the formula sheet is here at the back. We need an equation that's got pressure and volume in, and we are going to find that here. P1V1 equals P2V2 for a fixed mass at a constant temperature, which we're going to have to assume it is. Whenever I use this equation, I always write down what P1 and V1 equal and what P2 and V2 equal. So the volume of the bubble is 23 centimetres. So to start with, the volume of the bubble is 23 centimetres cubed. Then the pressure of the bubble is 297 kilopascals. The bubble rises to the surface. At the surface it will have atmospheric pressure, which is 101 kilopascals. And I need to work out what volume 2 is. Now I don't need to worry about the kilopascal thing or the centimetre cubed thing because they're all in the same units. So as long as I keep them in the same units, I can just use the numbers as they are. So I've got P1 V1 equals P2 V2. Normally I rearrange first, but for these equations I don't. I put the numbers in. So 297 times 23 equals 101 times V2, because then it's easier to see what I need to do. 297 times 23 divided by 101, and V2 comes out as 67.6 centimetres cubed, which doesn't seem ridiculously high, so 67.6 centimetres cubed. A student is interested in the way that submarines are controlled. She has several regular wooden blocks, a set of weights and a tank of water. Wood floats in water. The student plans to immerse the wooden blocks fully in the water and investigate the relationship between the upthrust and the weight of water displaced. Describe how she should determine one of the variables in this investigation. Now, upthrust equals the weight of fluid displaced, and I'm going to choose to work out the weight of the water displaced. It will help me for the next question as well. So weight of water displaced equals the mass of water displaced times by G. W equals mg. Now the mass of the water, I'm going to use the equation density equals mass over volume. So the mass of the water equals the density of the water times the volume of the block, or the volume of the whatever pushing it down. So the volume of water displaced is always the same as whatever is pushing into it. So the mass of the water equals the density of the water times the volume of the block. So overall, I can say the weight of the water equals the mass of the water, which is the density of the water, times the volume of the block, times by G, rho v G. And you come onto this a lot more at A level, that's why it's one of the harder questions at the end here. Therefore, what do I need to do to determine the weight of the water? I need to determine the volume of the block by measuring sides with a ruler and multiplying together. Then multiply by density of water and G, and they're constants, so you don't need to measure those. G to find the weight of water displaced. It's quite a tricky question, I think, there, especially giving you that choice. Then, our second 6 mark of the paper. Figure 26 shows a submarine stationary and submerged at a depth of 10 metres, explaining how pumping water into and out of the buoyancy tank affects the depth of the submarine below the surface. So currently it's stationary, and for it to be stationary, so a stationary submarine, I'm going to call it a sub, requires balanced forces. Now the forces on this submarine are going to be weight and upthrust. So weight must equal upthrust at this point. Now, upthrust is equal to the weight of water displaced. And from the last question, I know that that therefore equals the density of water times the volume of the sub now, not the blocks, times G. Okay, now the density of water is a constant. The sub has a constant volume. It doesn't get bigger or smaller. It gets heavier, but it doesn't get bigger or smaller. And G is constant. So the upthrust must also equal a constant. It doesn't change. You can't change the upthrust on the sub. Therefore, to make this move up or down, if we can't change upthrust, we're going to have to change the weight. So, to go deeper, we must increase the weight of the sub so that weight is bigger than upthrust. Therefore, pump water in. Putting water into the sub means it's going to get heavier. To go less deep or to rise, we must decrease the weight of the sub because we can't change the upthrust. So W is smaller than upthrust, therefore pump water out. And that should get you all 6 marks, but it's quite a hard question to try and explain, especially that bit about why upthrust is constant.